Hi friends, in this video we are going to discuss about how to calculate total current in the given network and also how to calculate the voltage drops across individual elements which are connected in the network and also how to calculate the power absorbed by each resistor in the following network. Okay, so this is the network we have and we need to go for the calculation of total current, voltage drop across individual element and also find the power absorbed by the each element in the given network. Okay, so now the solution is, first see the question number 1 is what? Actually in the given question, the question number 1 is the total current. So the total current means, for example, see here I am taking the step number 1 and step number 1 is calculation of total current. So total current IT is equal to how much? Okay, now see here we know that. So while we are going for the calculation of total current in any network, first we need to observe whatever the elements which are connected in the network, whether all the elements are connected in series or in parallel or the combination of series and parallel. If you know about the exact series and parallel combination of resistances, then only it is possible to find the total resistance. And after calculating the value of total resistance, now we are going to find the total current, because the total current expression, that is, so total current IT is equal to applied voltage, that is total applied voltage divided by total resistance in the given network. Okay, now see here applied voltage VT means what? 10 divided by RT means what? RT means, while we are going for the calculation of total resistance, we need to observe in the given network all the resistances are connected either in series or parallel or the combination of series or parallel. Now in this network all the resistances, that is R1, R2, R3, all are connected in series. So that is the reason why what we are going to do when we are going to find the value of total resistance, that is RT is equal to, so how to find the total resistance when all resistance are connected in series? So directly we can add all the values like this. So R1 plus R2 plus R3. Okay, when all the resistances are connected in series, to find the total resistance or equivalent resistance, just we need to do what? Just add all the resistances values like this. Okay, so if you are going to add all these resistance values like this, then you will get what? The total value of resistance, that is the value of R1 is how much? 2 ohms. The value of R2 is how much? 6 ohms. The value of R3 is how much? 10 ohms. Now here the total resistance is equal to, so ikkada manaki how much? Total 18 ohms. Now 18 ohm is the total resistance in the given network. Now what is actually our target? Calculation of total current. So total current IT is equal to VT divided by RT. Now we know that IT is equal to VT is how much? 10 divided by RT is how much? 18. Okay, now here 2 5s are 2 9s are. It means IT is equal to 5 divided by 9. So here when we are going to finding the value of total resistance, just first we need to observe whether the resistances are connected in series. For example, R are connected in series, then directly we can add like this and get the value of resistance like this. So that is the reason why if we know about the total resistance, just we need to substitute the value of VT and RT in the given in the formula, then you will get the value of what? Total current IT. Now here 5 divided by 9 means if we simplify this, you will get 0.555 amperes. Okay, so this is the value of what? Total current IT. Okay, now coming to the second one, that is what? The second one is calculation of voltage drop across individual elements. Calculation of voltage drop across individual element means what? So if you know about the calculation value of current, how much amount of current is flowing through the network, if you know, then it is very simple to find the value of voltage drop across individual element, because the voltage drop across individual element formula is what? Actually to calculate the voltage drop across any element, we are going to use the formula V is equal to I into R. Okay, so V is equal to I into R means V represents the voltage, I represent the current flowing, and R represent the resistance. It means when we are applying some voltage, that is V is equal to 10 volts in the system, the amount of current is flowing, that is 0.555. Now whenever we are going to find the value of voltage drop across any element, so we can simply find like this. So just see here. So the given network is how much? The value of this R1 is 2 ohms. The value of this R2 is 6 ohms. The value of R3 is 10 ohms. Now we are applying some voltage, that is, so V is equal to 10 volts. Now we know that in the given network, after calculating the value of current, we got the total current which is flowing in the system is what? 0.555 amperes. Okay, it means this much amount of current is flowing through R1, R2, R3, because all the resistance are connected in series, means the current flowing through R1, R2, R3 must be same, because in series connection current is always same. But the difference is what? Voltage. The voltage of across R1, R2, R3 will divide. That is the reason why in case of series connection, voltage, the current is same, but voltage is not same. Now what is our target? Actually our target is to find the voltage drops across individual elements. So that is the reason why what I am doing, to calculate the voltage drop across individual elements, just I am taking the voltage drop across R1 resistance is VR1. The voltage drop across R2 resistance is, assume, VR2. And the voltage drop across the resistance R3 is, for example, taking VR3. Now what is our target? Our target is to find the voltage drop across resistance. But whenever we are going to find the value of voltage drop across resistance, the formula is always what? So current into resistance. Because as per the Ohm's law, V is equal to I into R. We are using this formula to calculate the voltage drop across individual elements. Now here VR1 represents the voltage drop across R1. It means we need to substitute the value of R1 instead of this R. It means instead of this R1 R resistance, so we are going to substitute the value of R1. That is the reason why what I am doing, simply I am placing the VR1 voltage drop across this R1 is always given by the formula is, so VR1 is equal to I means what? Current is flowing through the network. The total current is flowing through the network means that the value of IT, total IT, is flowing through R1 only. That is the reason why. So voltage drop across R1 means the product of current to flowing through resistance into the value of resistance, like this. Okay, now here VR1 is equal to total current IT into R1. Now we know that the value of current is 0.555 into the value of R1 is how much? 2 ohms. So that is the reason why the value of VR1, while we are going to calculate the value of VR1, how to find the value of VR1? We can directly substitute the value of total current which is flowing through the resistance multiplied with that particular resistance. So by simplifying this one, you will get the value of 1.1 volts. Okay, so 1.1 volts. Now this is the voltage drop across what? R1. Now how to find the value of voltage drop across resistance R2? Simply, so voltage drop across resistance R2, that is VR2 is equal to current flowing through resistance IT into R2, because see here the total current flowing through the resistances is always same, because all these resistance are connected in series. Okay, now here VR2 is equal to the value of this total current is 0.555 into the value of this R2 is 6 ohms. Now whenever we are going to find the value of the voltage of across this particular resistance, so always we need to take what? The same current, because in case of series connection we always same current. If for example if it is parallel connection, we can go for another method. Okay, now voltage of across R2 is equal to Y. By simplifying this one, you will get the value of 3.3 volts. 3.3 volts. Now this is the value of voltage drop across R2. Now coming to the third one, that is voltage drop across resistance R3, that is equal to voltage drop across R3 VR3 is equal to the total current into the value of R3, that is equal to total current is 0.555 into the value of R3 is directly 10. So here the value of, by simplifying this particular value, you will get the value of 5.55 volts. Okay, so 5.55 volts. Now this is the manner we need to find the voltage drop across individual elements. But whenever we are going for the calculation of voltage drop across any element, first we are going for the calculation of total current which is flowing in the network. Like whatever the procedure we followed here, same procedure we are going to follow and get the value of total current IT. And after getting the value of total current, we are going for the calculation of voltage drop across individual elements like this. Okay, and please remember, the current is always same in case of series connection of resistances, and current is not same in case of what? Parallel connection. Please remember this point because this is very, very important point. Okay, so this is the calculation of current and calculation of voltage drop. Now we are going to find the calculation of power absorbed by the each resistor. Okay, so this is very, very important step. Now we are going for the calculation of power absorbed by each resistor. Now see here. So here again I am going to drawing the circuit. Again I'm going to drawing the circuit, and after that we are going to find how we are going to find the power absorbed by each resistor. Okay, now this is the actual circuit we have, and here, so this is a network we have. So this is R3 is equal to 10 ohms, and this one R2 is equal to 6 ohm. This one R1 is equal to 2 ohm, and V is equal to 10 volts. Okay, actually our target is what? Our target is to find the power absorbed by R1 resistor, R2 resistor, and R3 resistor. Okay, now here we are going to find the power absorbed by the resistance R1. Okay, power absorbed by resistance R1. Now here, whenever we are going to find the power absorbed by R1, that is P suffix R1 represents the power absorbed by resistor R1. So whenever we are going to find the power absorbed by each resistor, just see here, we need to take the square of the current which is flowing through that particular resistance into that particular resistance. Okay, while we are finding the value of voltage drop across each element, we are taking just product of total current into resistance. But when we are going to find the value of power absorbed by each element, we are always taking the square of total current into R1. Okay, now here we know that, so the value of total current flowing through this particular R1, R2, R3 is how much? So total current flowing through this series combination of resistance is always what? So 0.555. Now here the power absorbed by this resistor R1 is always given by PR1 is equal to total current square into R1. Now here we know that the total current is 0.555 whole square, and the value of resistor R1 is 2 ohms. Now here, by simplifying this one, you will get the value of, just see here, if you are simplifying this one, you will get the value of 0.61605 watts, and we know that the unit of power is always what? Watts. So here the total current square into the value of R1, because the power absorbed by this R1 is what? 0.61605 watts. Okay, it means whenever we are going to find the value of power absorbed by each element, we need to consider only that particular element value into the current flowing through that particular resistor square. Okay, so that is the reason why I am taking the power absorbed by the resistor R1 is equal to total current square. It means this amount of current is flowing through that particular resistance. That is the reason why square of current into that particular resistance, and substituting these values, you will get the value of 0.61605 watts. Now coming to the power absorbed by the resistor 2. Okay, power absorbed by resistor 2 is given by what? So power absorbed by resistor 2 is equal to, so current flowing through that particular resistance square into that value of resistance. This is given by, so 0.555 whole square into the value of R2 is 6 ohms. Now here, by simplifying this one, you will get, so you will get the value of you will get the value of, so into 6, so just see here, you will get the value of 1.84815 watts. Okay, so this is the power absorbed by the value of resistor R2. Now coming to the third one, that is power absorbed by the resistance R3, that is equal to power absorbed by resistance R3 is equal to total current which is flowing through that particular resistance square into the value of that resistance. Now here 0.555 square into the value of R3 is how much? 10 ohms. Now if you simplify this particular value, that is 0.555 square into 10, if you simplify that one, you will get the value of 3.08025 watts. Okay, so this value is the value of power absorbed by each element. Okay, so this is a manner we are going to find the value of current flowing in the network, and also after knowing the value of current, how to calculate the voltage drop across individual element, and after finding the value of voltage drop, then how the power, what is the amount of power absorbed by each element in the given network. Okay, so this is a manner we are going to find all the parameters for the given network. Okay, thank you so much for watching, and please do subscribe my channel for more updates. Thank you.